Hello everyone, welcome back to our channel. Do you know guys that how NotebookLM works? I think we most of us use NotebookLMs to for creating any docs or any PPT or any AI generated video, okay, based on your documents. But do you actually guys know that how actually it works? We'll discuss in this video. First of all, we're going to go with one example, okay. First of all, understand that how Google NotebookLM works. We'll go with one example, and based on this we will discuss that how we can actually Google NotebookLM works behind. Okay, Google actually work one system that is RAG. I think those who are learning generative or in tech background, those who have tech background, they already know that RAG based system. Okay, so what is RAG based system? Part you understand with the example. Okay, first we'll go example like first of all I'm going to tell you that first what things we did in Google NotebookLM. First, we created notebooks and uploaded source. Okay, first create a notebook and upload your source. It can be a PDF, Google Docs, or text file, or website, YouTube videos, link, everything, anything. Okay. Then NotebookLM automatically process them in chunks and content. Create embeddings. What is embeddings? We'll discuss and build an index, internal index. Okay, and it generates automatic summaries and identifies key topics connection for each source. Okay, and then when you ask a question, a request generation a system retrieves the most relevant chunks section from your source using semantic similarity. Okay, I think you not able to get it that how what is semantic similarity, what is embeddings. Don't worry, I'll discuss. So first I'll go with this example, easy example, so everyone can understand this. Like, imagine you have a small document and you sought a recipe for mango lassi. Okay, you have a document and where written how mango lassi will cook. Okay, it can be text file or anything or docs file, and just only written your document that how mango lassi are made. Okay, mango lassi. This is the text that written in your documents. Like mango lassi is a delicious Indian drink. It is made with ripe mangoes, yogurt, milk, sugar, and always use fresh mangoes for best taste. Preparation time is 5 minutes. Okay, this is your documents, and this document is written only this text. Okay, and from your case, when you use NotebookLM, you upload 2-3 books at once. Okay, very huge documents. Okay. First of all, we're going to discuss that how actually NotebookLM works. NotebookLM works use the same system under this, behind this. Okay. First, when you store the documents in vector database, like first when you upload the documents in NotebookLM, what they actually NotebookLM do they store the documents in vector database. Okay. First, the system split the big documents into small pieces of chunks, called chunks. Okay, they break them into chunks. Chunks means that if you have a 100 page of books, so it break into the one page in each chunks. Okay, like this. Okay, again, because AI models can't process very long text at once, because AI model can't process the whole books at once. Okay, that's why you have to break them into chunks. Okay, and small pieces and get better result. Okay, how splitting chunking happens? Simple way, split by sentence or fixed size, 100 200 words. Like every chunks have a 200 100 words. It can be 1 page or 2 page. Okay, and this is already mentioned when you use NotebookLM. Already fix this by those who are engineered made the NotebookLM. Okay, that how many words comes in every chunks. Okay, in our example, the recipe is split into 3 small chunks. We split the recipe into 3 chunks. Like one is mango lassi delicious Indian drink. It is made with ripe mangoes, yogurt, and sugar and pinch of cardamom. Okay, cardamom. It is referring in summer, representing summer. Mostly mango lassi used in summer. Okay, also have written in the inside chunks documents. Always use fresh mangoes and for wastage. Preparation time is 5 minutes. These are 3 chunks, and each chunk is often then converted into a vector embeddings, a list of numbers that represents the meaning of the text, like this. Okay, chunks 1 vector 0802 -05. It means that every chunks convert into vector embeddings. Okay, and this can actually take your language similarity. Okay, like ingredients, first one for ingredients, when to drink, second one second chunks, and third chunks for tips. Okay, these are three chunks we have, and these chunks, these vectors, the original text of the chunks are stored in the vector database, but these things are stored in the vector database. Okay, we can't store the total these things, okay, as a text. We store them as a vector database, as a vector in vector database. Okay, each entry also keeps metadata. Also, each have also keep the metadata. Metadata means data, data of the data. Okay, it means that how many pages are have in the chunks, total, source of the document. Okay, everything we also store in the metadata as a metadata. Okay, inside the vector database. Okay, now the document is indexes and ready. Okay, then user asks a question, like you ask a question to Google NotebookLM. What ingredients are needed for mango lassi? Mainly we ask this question. For example, the system converts your question into a vector 2. The system also converts this into a vector. Okay, using the same embeddings model, like vector, how we converted them like this. Also, the question also converted them into vector. Okay, like this. The vector database quickly searches for chunks. Those vectors are more similar. Like those vectors are more similar from the chunks. They searches the this question inside the chunks like this. Okay. It uses the math like cosine similarity. They perform a mathematical calculation, that is cosine similarity. And those vectors are most similar from the question. We will pick up this question, pick up this answer with your question. Like it finds that retrieve the chunks one because we ask the ingredients. So chunks one have the ingredients. So it finds the chunk, retrieve the chunks one most relevant, and maybe part of chunks 3. Okay, it can be only those chunks are similar from your question. That is the how they pick up these chunks. Okay, and mango lassi is a delicious Indian drink. It made with ripe mangoes, yogurt. We find out these chunks based on your question. We will do a similarity, question similarity. Those vectors are similar to the question. We pick up this answer. Okay, and next thing is that augmented POM. And till now we didn't use any LLM. Okay, don't use LLM. Now it comes. It's the LLM. Okay, the system creates a new POM for LLM. We create automatically they create a POM for LLM. What the POM is? They answer the question using the following context. This is how we made a POM. That context is mango lassi is a delicious Indian drink. It made with ripe mangoes, yogurt, and the answer and yogurt. Okay, they answer the question with using only the following context. Okay, oh, it is all yogurt, milk, sugar, pinch of cardamom. Question: what are the ingredients are needed for the mango lassi? Mainly these two things we send to the LLM. Okay, what things we pick up from the chunks and with the question. Okay, only two things we send to the LLMs, and we tell the LLM that give me the answer based on this to answer and question. Okay, and then LLM generates answer. LLM generates its own answer because LLM have the capability to give the answer, write the formatted way to any text. So now the LLM reads the context and question the answer. You need ripe, ripe mangoes, yogurt, milk, sugar, and pinch of cardamom. Okay, and this is the LLM answer. Okay, and it also add a citation like source, recipe, documents, chunks one. Okay, anything it can be added, but we also need these things. Okay, actually this is how LLM NotebookLM works. Okay, they break them into embeddings. They find the similar chunks based on your question using the cosine similarity. It uses a math concept behind. This is actually netbook LM works. We'll understand this with a simple example. Okay, and this is also written same thing. Okay, like embeddings. What it is and vector data representation or semantic search. Uh, Generation, the retrieve context is feed into a large language model. Total this thing into feed into a large language model, and powered by latest Gemini variants such as Gemini 3. There's a Google model they are using behind this. The model generates a response only from the provided context. We tell them the NotebookLM that only give the answer only based on this context. Okay, and then add inline citation linking back to exact quote and passages in your source. Okay, it add the same thing like citation. Citation means that how you actually ask send see the question. Okay, answer like this. Okay, in a formatted way, and this thing actually work. Okay, and mm, the the model generates a response only from the provided context, and it then adds inline citation. Okay, and this closed book approach makes response highly accurate, verifiable for your specific materials. The large context window of GNM models up to 1 million tokens, so very high, with NotebookLM supporting 50 sources and tolerating millions of words. It allows handle entire books, search, research, collection, large transcript, and at once. We'll discuss with a simple example, but NotebookLM have more capability. Around 50 sources. You can edit 50 sources. Okay, like PDF, Google Docs, website, YouTube videos, audio files, anything you can upload in the Google NotebookLM. Google NotebookLM give the answer based on your documents. Actually, this is how the Google NotebookLM works. This is the first user question. Retriever searches vector database, relevant chunks retrieve from your based on your question, and augmented prompt question plus relevant chunks, like we send them to the these things to the LLM, question plus relevant chunks, LLM generate answer for you and give the answer to you. Okay, these are actually NotebookLM work, and this concept called RAG, Retrieval-Augmented Generation. Okay, actually the Google NotebookLM behind this concept RAG. Okay, so this is the video. If you like this particular video, please give a thumbs up, and if you have any query, please let me know in the comment section. And if you like this video, please subscribe to my channel. Thank you guys.